Hello, my name is Andrew Boel. I'm a senior engineer here at Havoc, and I'm here to talk to you today about game physics and what that means for the Intel Core 2 Duo and Core 2 Quad based systems. Game physics is what makes the game world a truly immersive, interactive and realistic place. Havoc's involvement with game physics is to create a truly interactive environment through the use of ragdolls, vehicles, dynamic objects. But game physics tends to be a computationally heavy task. The way the industries respond to this is by increasing the number of cores on the CPU, as for example with the Intel Core 2 Quad processor. Havoc HydroCore is a software solution that accelerates the game physics by dividing up the workload to run on multiple cores. So if you take a system like the Intel Core 2 Quad-based system, that allows us to effectively break the workload into four distinct tasks. In this example, we have a brick wall and a sphere that collides with that wall. In Havoc, we have this concept of a simulation island. In this example, each simulation island is colored differently. And this allows us to dynamically, at each frame, identify objects that are closely interacting. In other words, you can say that one simulation island is independent for that frame from another simulation island. And this gives us a very, very powerful way to break up the simulation into a number of parallel tasks. And really all that means is we look at a world and we identify what objects are simulating together or what objects are interacting together. Or you can probably already see that the more cores that you throw at Havoc, the faster and the more accelerated the work is going to be. So let's take the simulation concept a step further. In this example, we have three simulation islands, one for each of the characters and one for the wall. At this particular point in time, the simulation can consider these three islands to be independent and not interacting. This character is a traditionally animated character. There's two animation cycles, a walk and a jump. All the effects you're seeing where the character interacts with the wall are being handled by Havoc Physics. So Havoc Physics is responsible for procedurally changing the way the character behaves when he collides with the wall, when he falls on the ground, when he gets stuck on the wall. And this really allows for a much more immersive experience. The character is aware at all times of his environment. The demo we're going to see now is a demo of ragdolls, which are a key part of making a game an immersive experience. The ragdoll is very much a next generation effect. It's an effect that breathes life into characters. So in this example, we're going to take a look at a very computationally heavy physics scene. What we're looking at here are 200 ragdolls being fully simulated. Each ragdoll consists of a number of elements corresponding to the legs, the head and the arms. So there's 2,200 rigid bodies in this scene, and there's 2,000 constraints holding those rigid bodies together. So it's a very, very demanding scene for any processor. In this example, we've seen between 1 core and 2 core at least 1.7 times speed up. So this is currently running on a Intel Core 2 Quad processor, but currently we're only using 2 of the cores. If we scale the simulation to use 4 cores, we see close to a 3 or 2.6 times speed up. It's really the power of the HydroCore system and an architecture like Intel's multi-core systems that really allows us to push the boundaries here. In this technical demo, we're going to see how the Havoc simulation scales as the buildings in this demo are destructed. I'm controlling a tank and I'm able to fire projectiles at these buildings. As you'll see, the buildings are dynamically fracturing as I'm interacting with them. This kind of scale of simulation is really only possible when you're running on a system with multiple cores. It's the combination of Havoc Hydro-Core running on the Intel Core 2 quad processor that allows for such a large scale of destruction and simulation. So I think one of the key points that we've seen from this so far is that software needs hardware solutions, and especially a system like Havoc, which is computationally heavy and a real-time system. So the software solutions that we've been provided by Intel, being primarily the Intel Core 2 Duo and Intel Core 2 quad-based systems, really allow us to deliver the astonishing immersive gameplay experience that you just can't do on a single core-based system. We hope you've enjoyed this presentation about how the Intel Core 2 quad processor allows Havoc to create a truly immersive gaming experience. So let the games begin.